Here is a little story about generating maintainable tests using the Prodo framework. So back in the day, developers used to write tests by hand, typically using unit test framework. And with traditional languages, at least, it was usually typed and fairly easy to maintain because you had a lot of feedback from your dev tools and your type system. And then developers started to cost a lot of money. People started to use dynamic languages for speed, and writing tests manually didn't really scale. So we started to automate, for instance, by recording tests from the browser. And this unfortunately created a maintenance hell. So what I mean by maintenance hell is easily illustrated by looking at a typical Selenium IDE workflow. So this is a little to-do application, and what we're going to do is use Selenium IDE to start a new project, point it at our local environment, and starting recording a list of actions. So here we're adding a new item to our to-do list, toggling it, deleting it. And that's it for the test. So it's really quick, really just a few seconds. Give a name to a test, say add and remove. And now we're able to replay this test, clicking the run button. And what's happening here is Selenium is essentially going through a list of steps, each time waiting for an element to be on screen and coding the appropriate DOM event. So all of that was fine for generating one test, replaying it, but now what is the code changes? So here what we're going to do is simply add a div element around the button inside the item React component. So not a very material change. In fact, when we switch back to our application here, there's very little that a QA person could be able to notice, right? The button just works as before. Now, if we reopen our test from Selenium, say run current test, most of the first steps are going to run just as before, but when we reach the last click event on the button, it's essentially going to hang forever. And so here I'm quickly losing patience, clicking stop execution, and we see the problem is with this button element that wasn't found. And so if I'm very knowledgeable about the code, and if I know the last change, I'll be able to know how to fix it, right? I'll just add this this extra div in the selector expression, and if I run the test, everything is going to work smoothly. But obviously it takes kind of a bit of knowledge of the code to be able to do that, or change in the code. And now if I save my project, there's a way obviously to get this Selenium test back into your file system, which is by saving these .site files, which are essentially JSON objects. But these JSON objects themselves are not really the readable type, right? And maintaining them going forward is going to be hard. So just to recap here, so what went wrong is that we're using fragile CSS and DOM artifacts. We're producing untyped JSON files, which are going to be hard to maintain. We're waiting forever for things to render. The tests are essentially a bit slow to run, even though we could obviously parallelize. And the approach is 100% framework agnostic, which is great from the point of view of Selenium, meaning that they can find more customers by not imposing constraints on how to build apps. But we'll argue that it's a bad thing from the user perspective because really missing out on better automation. So now, just for comparison, let's look at Prodo's framework-aware alternative. And what we're going to do here is essentially going through the same app and record the same test. So what you notice here on the right is these DevTool panels that come to the Prodo framework. And in this panel, we get a kind of real-time log of all the actions that are being performed on the application. So here we did a new to-do, then we toggled the second one, we toggled it again, and we deleted it. And one of the strengths of the Prodo framework is that it's really tracking a lot of things. So if you look here, for instance, we've seen the previous state of the application, or the next state of the application, which now has this extra item for get bread. You'll be able to see the changes to the state in the form of patches. So here we're saying that we've added something to the path state to-dos and then the generated ID. And then finally we record all the side effects of the actions. For instance, here the new to-do item is calling an effect called random ID, and the generated value here was this 0.838 string. So now that we have all this information, the DevTools is able to send that back to a DevTool server, essentially. So here I'm clicking an action object, so giving the action button at the bottom, giving a name to my action test. It's the same as before, add and remove. And if I switch back to my file system, I now see in this folder called test generated actions, I see a new file called add and remove, which is now essentially a JS file describing all the high-level important steps of my test. So initializing a store with initial state, using the side effect that we're recording previously. I then wait for a series of asynchronous actions, and at the end, the test here is to check that the state is going to be equal to the desired state at the end. And this is, as you can imagine, there's a lot of details here, so we wanted to make this very configurable. So there's this config.js file somewhere in your that we leave alongside your code, where you can essentially tweak the templates, right? So here the test we're looking at is this save action test, and we configure the directory where it's saved, but then we also configure the path of where actions are imported. We configure the test name, where to put the initial state, the list of actions, and the exact test we want to do at the end. So this was just a little parenthesis about the config, but we've seen one type of test about actions. Let's now look at another example for the save render test generation. And this one is in fact simpler, because what it does is just looking at a current state of an application, trying to render it so that we catch obvious rendering errors. And for the sake of regression testing, it states that we expect the HTML to match the snapshot. So let's use that inside the application. Let's start from the scratch. We started from the to-do applications, again adding another item, taking a snapshot here just for bread, then toggling it, taking another snapshot, say toggled, and finally, just as an example, deleting all the items and taking yet again another snapshot. So that was very quick, and what happened there is that we generated three new tests in a render folder. So this one starts from the initial state of my application with only one item milk, which is not toggled, and this generated item get bread, which is not toggled. And all we say here is that we expect the rendering of this component to match, let's say, snapshots. Likewise, we have another test in a different state where there's nothing in the to-do list, and another one where there's the second item is toggled. And so well, what we leverage here is essentially just a built-in mechanism to save and update snapshots, and here is what they look like on the file system. And now, if we switch to the Jest console, which is here, we see that all the tests for now have passed. And so now comes the interesting use case, which is what happens when I actually change my source code. So we're going to start with the same example, adding a div around the button inside the item component. And once again, this is not a change that is really visible to a QA person, but this is a kind of change that actually breaks the regression test here, right? Like here we configure tests to be strict about snapshotting HTML. And one benefit of using the Jest interface is that it gives you a really nice summary of what has changed exactly, right? So here it's highlighting that this part of the HTML now has a div around it. And so if we're happy with that change, we can just say, okay, update the snapshots, and then the tests are going to run again. And at the end of this new run, everything is now passing. So this sort of change was kind of easy to handle. Now, what if we make a more material change, right? Let's say we change completely the type of our application and say that to-dos text are now using the field called txt instead of text. So now TypeScript is going to become very helpful. It's going to tell us in our source code what to change. So in fact, there's only one place here we're using it. And in the test, it's going to do the same. It's going to tell us exactly which field should change. So for instance, here, this property here should change. We can look also at our render test. Here, the snapshots are not really affected, but the source code again needs to be fixed because we are now using the new type for my to-dos. Once again here, so if you're a TypeScript expert, you know that there's actually a faster way of doing what I'm doing here. Here we could have using a rename feature, or we could have called a quick fix command from VS Code. But essentially the point I'm trying to convey is that you get feedback before having to rerun the tests, right? So you can very quickly update all your tests and be in a good spot. So that was for the Prodo the demo. What I think went well here compared to the Selenium case is that we're no longer relying on reverse engineer CSS or DOM expressions. We've generated TypeScript which is much easier to maintain and gives them more feedback in our editors. We've produced tests that are run without waiting for DOM elements to render. We've separated pretty clearly just the rendering of a given state and the modification of the state with two different types of tests to make sure that everything runs fast. And perhaps most importantly, we've taken care of the state management aspect, right? We've taken a full snapshot of all the effects, all the states, all the actions, which means that the tests are essentially more reproducible and less flaky. And the story doesn't end here. In this short example, we've mostly looked at render and action tests, but there's all sorts of tests you could add very easily, simply by adding kind of new templates in the config file we looked at earlier. If you'd like, for instance, you could go try and go a level deeper and track on-click events based on component names and props, for instance. Another way to extend what we saw would be to use more plugins of the Prodo framework, which is a full stack framework, and instead of just handling this front-end state we saw here, we could handle likewise your authentication state, your local storage, or your database. And finally, now that we've got types, there's room for a lot more automation as well around optimizing these tests that we generated, right? So for instance, if you record 10 different snapshots with a state object which is very similar, then we can refactor the common part in a different file, and then only modify them for each of the tests if that's something that can kind of simplify the overall code base. So that was it for a quick overview of what we mean by generating a maintainable test with the Prodo framework. And if you have any question, ping me at bruno@prodo.ai.